Welcome to this week's episode of the Practical SQL Server HA show. Welcome if you're joining in for the very first time. Welcome. The purpose of this show is to share insights, lessons learned, best practices, recommendations, sometimes blunders, errors, mistakes that I've made, and some of those that I've seen in my customers' environment so you can prevent them from happening, specifically on building, designing, managing SQL Server high availability and disaster recovery solutions. But of course, it goes beyond that because databases don't live in a vacuum. So I also cover the ecosystem, things outside the database world that directly affect high availability and disaster recovery. If this is the first time, or if you've been watching some of these episodes, thank you for your support. Really appreciate it. I also appreciate some of the comments, your suggestions on the topics that you want me to cover. Thank you. Really appreciate those because it's really challenging sometimes to think of the topics. What I usually do with the topics is I ask my customers, of course, try my best not to mention their names to protect the innocent, and also learning as much as I can from the experience that I've gathered working with their environments, my customers' environments, and sharing them with you with the purpose, again, of helping you in your journey of deploying or even managing after implementation of a SQL Server highly available or high availability solution. This week's episode is all about always on available groups implementation beyond the DBA world. Kind of difficult trying to find a picture for that. It's kind of like out of this world. It's interesting because this is kind of like a look at the journey and the evolution of the database administrator career. Because when you start to think about it, well, always on available groups is a SQL Server feature, and as a SQL Server professional, then the focus would be more for the database administrator, but it's really beyond that. And like I said, this is kind of like a trip down the memory lane of the evolution of the database administration career. Back in early 90s, early 2000s, majority of the database administrators and their task involved working with servers, spinning up servers, configuring them, racking and stacking those servers onto data centers. That's part of their day-to-day. I remember working with a DBA team from way back late 90s. I was not officially a database administrator. I was kind of like a systems administrator, but I was working with a team of database administrators. And I remember vividly how, and these are Oracle DBAs, by the way, how they would be pushing those Solaris Spark machines, like big Solaris Spark machines, where they would push them between data centers because they're so heavy. Either they would grab one of those trolleys, put the servers on top of them, and they would drag them around to move them from one data center to another data center. It's interesting how those roles have evolved. As more databases were deployed, those people, same database administrators whose role involved racking and stacking servers, configuring hardware, evolved into writing SQL queries, creating stored procedures, functions within the database, performance tuning. Yes, because now we're collecting and storing more data in our databases. So the evolution of the role went from I'm more of a DBA / sysadmin. I work with servers. I work with systems, I rack and stack servers, to I work with databases, and I also am a quote-unquote database developer. And the evolution is driven by the need of that era. Like I said, early 90s, early 2000s are when companies are starting to adopt more of these database infrastructures. And then as the data collected increased, there became, or there has been a need for, again, performance tuning, writing code for the database. And now with always on availability groups for SQL Server, it is a little bit challenging, especially if it's your first time deploying always on availability groups, to look back into what was a few decades ago to what is. And so the question you need to ask yourself is, do I need, or do I have rather the skills needed in order to make this thing happen? Okay, like I said, beyond the DBA world. I remember when I first did my SQL Server always on availability groups, the Senior DBA's Ultimate Field Guide training class back in 2017, one of the things that I asked the attendees was their background in building infrastructures from the ground up. Because now always on available groups rely on Windows Server failover clustering, which interacts with so many systems outside of SQL Server. And there was one DBA there that said, hey, I never did. So part of the exercise was to build an infrastructure from the ground up. From the ground up. And at the end of that exercise, like, I've been a DBA for 10 years. I've never done this before. And that's also the reason why I created an online course specifically for that. I'll probably drop a link to that online course. But the idea behind that is to gain the skills and the expertise to build the infrastructure where you will building your always on availability groups, because you don't just use SQL Server Management Studio, run the wizard, and expect everything to work. Well, there's an infrastructure underneath that, like the foundational infrastructure built on underneath for your always on available groups to work. Unfortunately, though, with large organizations where you have segregation of duties, somebody else needs to do that. And sometimes, while they may be subject matter experts in their field, they don't know how it, what they're doing impacts always on available groups. So we are going to be exploring the world outside of the database administration world that would impact always on available groups, particularly implementation. And my biggest advantage is I came from that world, late 90s, early 2000s, where I was a server admin, sysadmin, data center engineer, and this was kind of like my background. I did a lot of stuff within SQL Server, from performance tuning to analytics and data warehousing, but I decided I want to stick with this. That's one of my biggest advantage. I was just lucky that I had the right background in preparation for going into SQL Server high availability, particularly always on availability groups. So again, we're going to put on multiple hats in order to understand the world outside of SQL Server to properly implement an always on availability group. Okay. First one, and I already hinted on this, is proficiency in Windows Server failover clustering. And with a side note there, and dependent technologies. Always on availability groups, if the goal is high availability, relies on Windows Server failover cluster for Windows. For Linux, any form of cluster resource manager, typically Linux Pacemaker or third-party tools like the H2I, you're sitting on a cluster resource manager. It's the cluster resource manager that is responsible for making always on available groups highly available. That's also one of the reasons why I did not really like the idea behind the read scale availability groups. The naming, that is. I like the concept. I don't like the naming. Because read scale availability groups can run without Windows Server failover cluster. The question then remains, is it highly available? Of course not. There's no cluster resource manager that would help achieve high availability. Okay? Unfortunately, the people at Microsoft Marketing named it availability groups. How is it availability group when it cannot be highly available? Just saying. I'm not a marketing person. I don't know how to name products. but I have opinions about it. Anyway, if your goal is high availability, you need to have a cluster resource manager. That's the foundation that always on available groups sit on top of. Okay, and because majority of the deployments out there are still on Windows, we're focusing on Windows Server Failover Cluster. That Windows Server Failover Cluster that Windows Server Failover Cluster is what your availability group sits on top of. It depends so much on that. So as a database administrator, if your only focus or if your only exposure is within SQL Server, you have to step outside of SQL Server, be proficient in Windows Server Failover clustering to understand how the two work together. Even if it's not your job, again, in larger organizations where you have segregation of duties, typically Windows Server Failover clustering deployment is given to the Windows sysadmins. They're taking care of that. But here's the thing, and I say but. Despite the fact that they're subject matter experts in their field as Windows sysadmins building Windows Server Failover clusters, sometimes majority of them are not aware of how always-on availability groups work. Okay? They're not aware of how always-on availability groups work. And so they're making modifications to the Windows Server Failover cluster that's detrimental to the operation of always-on availability groups. One example of this is manually checking the possible owners option within the availability group role inside the failover cluster. That's a no-no. That has to happen inside SQL Server, because SQL Server is the one writing or triggering the writing of that record of the possible owners list inside the cluster database. So even if you're simply you're restricted to working with SQL Server, you have to be proficient in Windows Server Failover clustering. Okay, how to build it, how it works, how the quorum behaves, what contributes to achieving quorum, how heartbeat affects quorum, how networking contributes to that. We'll talk about that in more detail in the next item. But again, even if you're restricted to just performing the tasks of a SQL Server database administrator, you got to be proficient in Windows Server Failover clustering. That way, you can communicate what's necessary to your Windows Server Failover cluster admins, your Windows sysadmins. You can talk to them and communicate to them how any tweaks that they make on the Windows Server Failover cluster can impact the availability of your availability groups. One common mistake that I see in Windows sysadmins managing Windows Server Failover clusters with availability groups is manually failing over the availability group from one node to another using the Failover Cluster Manager or PowerShell commands for failover clustering. Nope. And then they wonder why it's not failing over. There are other things, and that's of course in the realm of SQL Server database administration. Just because you manually fail over doesn't mean it is guaranteed to fail over, because there are prerequisites or conditions that need to be met in order for manual failover to be successful. Okay, but that's also, again, it falls into your responsibility as a SQL Server DBA. So beyond understanding how availability groups work, primary, secondary communication, data replication traffic with the transaction log records, you need to be very proficient in Windows Server Failover clustering. Notice that I said dependent technologies, because Windows Server Failover clustering depends on Active Directory, depends on DNS, depends on networking, which leads me to the next point. You have to have a good understanding of network administration fundamentals. This is not to say that you need to be a CCNA or Cisco Certified Network Administrator, or you should be a network administrator. Just basic fundamentals, like how data is sent from primary to the secondary. What constitutes a successful connectivity test? What is necessary in order for a client application to connect to a server application? And that's how I look at it, because the secondary replica functions as a client to the primary replica. Primary replica is talking to the secondary is receiving transaction log records and sending acknowledgement message back to the primary replica. Again, I look at it in a client-server architecture where the secondary functions as a client application to the server, which is the primary replica. So network administration fundamentals, like how do I validate whether I do have connectivity to my replica from the point of view of the client application, from the point of view of the replicas. I mentioned the data replication traffic because there could be cases where the primary could not send transaction log records to the secondary, and all of a sudden your databases are in suspended state. Okay? And even though you are forcing the resumption of the data movement between primary and secondary, you're not having any successes. Why? Maybe there's something blocking the traffic between the primary and secondary, like firewall rules. Maybe the default port number was blocked because the firewall rule was rolled out. So a couple of these things, right? And understand basics, like I said, fundamentals. How do servers talk to each other? How does a client application talk to the server? Those are network fundamentals. I remember working with a customer from a couple of years ago where we were doing simple troubleshooting tests. Their availability groups were offline, okay, and they were looking at their monitoring tools. We managed to bring up the availability group. We looked at the monitoring tool and we realized, hey, the primary could not connect to the secondary. They started running all of these tests, ran Wireshark in between, and the only thing that I did was I did a simple TCP and port connectivity test, and I found out, hey, I cannot reach the secondary from the primary. Simple. Because I understand network fundamentals, how systems talk to each other, and how, in this particular case, the replicas talk to each other. And all I did was to simply check, hey, primary could not talk to the secondary. That's probably why the databases have been suspended. Once the network administrators managed to fix the TCP port connectivity between the two, we simply resumed the data movement between the primary and secondary, and everything was back to normal. Again, simple understanding of network administration fundamentals. This also ties back into how important the network is when it comes to keeping the failover cluster highly available. Because your cluster nodes are talking to each other. Guess what they're using to talk to each other? The network. So part of that is also checking, hey, can node 1 talk to node 2 and vice versa? Communication goes through the network. You cannot overemphasize the importance of network fundamentals. And again, as a database administrator, sometimes you don't have visibility of what's going on in the network. Like for instance, the network admins might decide to tweak the settings in the network for improved quality of service and realize, hey, that server over there is generating massive amounts of transactions, or massive amounts of data, because they don't know what the purpose is. It's generating massive amounts of data, and we don't want that to saturate the network, so they will implement quality of service, not realizing that they're putting your databases at risk because your redo queue might build up, or the send queue might build up because they're tweaking the quality of service on the network. Again, just basic understanding of network administration fundamentals will help you as a database administrator when you're about to implement an always-on availability group solution. The third one, okay, so buckets outside of the DBA world. The third one is understanding of virtualization fundamentals and related technologies, I should say. It has become kind of like a standard or the go-to approach. New SQL Server deployments will be on VMs. whether that's Hyper-V, VMware, although back in the days, VMware was the standard, but now customers are moving away from VMware after the Broadcom acquisition. So they're moving to other alternatives. Proxmox is one thing, Nutanix is another, but it's become a go-to platform. Virtualization, that is. Could be on public cloud infrastructures, on-premise private cloud infrastructures, but it has been, like I said, the go-to nowadays. If you're deploying a new SQL Server, it is probably going to be on a VM. And you, as a DBA, sometimes you don't have visibility of what's going on because they would, the VM admins would just give you the VM. You would ask X amount of CPU cores, X amount of RAM. Sure, we'll give it to you. Not understanding that this is not quite the same as all the other workloads. If you really dig deep into the overall gist of virtualization, it's standardizing infrastructure across the board. That's on the assumption that every single network service has the same workload. No. Okay? That's one of the reasons why, again, most of the time, VM admins are simply following recommended best practices from the vendor. VMware, Nutanix, Microsoft Hyper-V, even. They would simply follow recommended best practices, but those best practices were not designed with relational databases in mind. They were designed for network service infrastructures. And so you're looking at web servers, application servers, DNS servers, domain controllers that do not function and have the same performance profile as a relational database. So what ends up happening is, sure, they will give you X amount of CPU, X amount of memory, not realizing they're over-provisioning or under-provisioning, because that's how they've done it in other servers that they're provisioning with their VM templates. As a SQL Server DBA, you need to understand how virtualization works, like the assignments of CPU cores, the assignments of the virtual RAM, specifically for the platform that you are deploying into. Okay? Because incorrect configuration of the virtualization platform, meaning, oh, they gave you 64 V cores with 128 gigs of RAM on this particular VM, not realizing that underneath the physical machine has a certain NUMA configuration that is not in alignment with how SQL Server manages NUMA. And that would cause performance issues that could impact your availability group performance. And when I say availability group performance, the way SQL Server responds to that will cause waits, long waits, until it causes an outage to your availability group. Okay? Because, again, SQL Server needs compute, memory, and storage resources. If that's a VM, is the VM over provision? Meaning, well, you gave me 64 V core or vCPU, yet my physical machine only has 48 V core over provisioning. Or I have 128 physical cores on my machine, but I got like 4 sockets. And each socket has a maximum amount of RAM. So you're telling me that in order for me to access X amount of RAM, I have to cross physical CPUs on the physical machine just so I can use that in my VM. So understanding how all of these work will give you insight as to whether what is assigned to the virtual machine is proper in order for your available groups to work properly. Worked on a case last year. This was very recent. Worked on a case where the VM had 100 and not even 128, more than 128 vCPU. When I asked the customer what the physical machine was, make, model, how many physical CPUs, I was surprised that they were even, I was surprised that they assigned X amount of vCPU cores. They thought hyperthreading was a full-blown core, And when I asked, why did you configure your virtual machines for this? Well, we had issues, performance issues with lower CPU cores. We increased the CPU core, and we still have problems. Not realizing, because of the context switching happening on the physical machine layer with the physical CPU and the physical RAM, it's causing issues on the VM that is causing outages, because availability group needs the compute and storage and memory resources. For that matter, it could not access it because of the way it's configured. They're getting and experiencing outages. We had to tweak the VM down from, I believe, 100 something vCPU to less than 90 plus CPU, and the performance. They were happy, to say the least, that they're no longer experiencing performance issues that were leading to outages with their availability groups. So understanding virtualization fundamentals and related technologies. Are you using virtual networks, virtual SANs, virtual everything? Because you also need to understand, again, going back to understanding Windows Server failover clusters, understanding network fundamentals. Okay, you cannot see what's happening on the physical layer because everything's virtual. So asking the right questions so you can have that conversation with your virtualization admin to make sure that, hey, both virtual machines are part of my Windows Server failover cluster. I don't want them to end up in the same physical host. So anti-affinity configuration should be enabled, because what's the point of having two virtual machines for your Windows Server failover cluster if they end up on the same physical machine? If that physical machine dies, that's a single point of failure. Okay, so stuff like that. Understanding virtualization fundamentals, because it's a standard nowadays. SQL Server databases will be deployed on virtual machines, even public cloud infrastructures, that is, right? So those are the three key things that are outside of the DBA world. Okay, we're looking at stuff outside of SQL Server, stuff outside of your normal day-to-day responsibility as a SQL Server database administrator that impacts the databases sitting on an availability group. You need to be proficient with Windows Server failover clustering, even if you're not a Windows sysadmin, even if that is outside the scope of your day-to-day responsibilities. You need to communicate the right way to configure Windows Server failover clustering so that your Windows sysadmins will spin it up, configure it, and tweak according to the needs of your always-on availability groups. Okay. Same thing with network fundamentals. The goal is not for you to replace your network admin. I wouldn't want that too. It's not sexy. To understand what constitutes the networking behind what makes Windows Server failover clustering work, what makes always-on available groups work, so that you can have that conversation with your network administrators when it comes to exemptions on ports, firewall rules on specific port numbers. And the third one is virtualization fundamentals. Just understanding that, because at this point, if you're deploying SQL Server, it will be on a VM. So understanding virtualization fundamentals, understanding specifics of that virtualization platform that you're deploying into, whether that's a VMware, Nutanix, Hyper-V, or Proxmox. I don't know if how the support would look like for SQL Server on Proxmox. But understanding that will give you like talking points with your virtualization admin on how to properly configure virtual machines specifically for SQL Server, specifically for deployment of always-on available groups. All right? That is about it for this week's episode of the Practical SQL Server HA show. And again, if you're at that stage where you're looking at implementation, you already have a plan, you already have a reference architecture in mind, and you want help on the proper configuration and deployment of an always-on available group solution, or you already have an existing one, but your staff is not ready, you don't have the manpower to maintain it, but you definitely need that, and you want your staff to be ready, use that link on the screen schedule a strategy session, and this link will lead you to my calendar page where you can pick and choose a time that works for you. In that call, we're going to be doing three things. One, be clear on where you're at. Are you in the design phase and you need help with creating the design and eventually implementing it for production deployment? Maybe, again, you're in that stage where you already have something in production. You're not quite sure if this is something that is stable because you might not be aware of some gaps, and you need somebody to have a look at it, review it, do a quick, extensive health check. Second, we will again be clear on what the goal is, and third, come up with a strategy that would help you get to where you need to be. Okay, use that link on the screen, schedule a strategy session, and I look forward to having that conversation with you, helping you in any way I can. All right, that is about it for this episode of the Practical SQL Server HA show. I look forward to seeing you again